Assalamualaikum warahmatullahi wabarakatuh. So this is discussion on the solution of example 1, the half-wave rectifier using diode and connected with a resistor load. The example 1, the question is the source is a sinusoidal 240 volt RMS and oscillate at 50 Hertz. The load resistor given is 20 ohm. So determine A, the average output voltage, B, the average load current, C, the average power absorbed by the load, and the last one, the power factor of the circuit. So for the first step, what you need to do is to identify which equation need to be used. Okay, so referring to the notes, so we have already know that V at average is okay, V out average is referring to Vm over pi, and while for V we have also another one, V out RMS, which is this one is Vm over 2. Okay, so for the first question, the average output voltage, so definitely we need to use the first equation here. Okay, from 1. So we need to convert the RMS into the maximum output. So without average is actually just multiply with square root 2 and 240 volt RMS over pi, and you should get around, this one is 339 volt over pi is given as a 107.8 volt. And for B, the average load current. So the average load current is I out average, even though the equation is not given in the notes, but you should already know that if the load is a pure resistor, so you just use the Ohm's law equation. So V out average over the R load, which is simply 107.8 volt over the resistor value 20 ohm. This will give you the answer of 5.4 ampere. And for the question number 3, which is the C, the average power absorbed by the load. So this need to be carefully carried out because most students will be confused on which equation to be used. Okay, so for recall, so we need to know that for P average, always use I out these equations, or square over R. Okay, and for my solution here, I am using this, the first formula. Okay, so what I need to do is you can actually use also V out RMS or any else, but for this solution I am using these first equations. So to calculate what is my I out RMS is just because this is resistive load, so you can simply use the Ohm's law to get the current. Okay, so we have already, okay, so V out RMS, so you need to have put here, so of the output is Vm over pi over R. So this one will give you 169 volts over 20 ohm, and the answer is 8.425 ampere. Okay, and the right now your P out average, you can use I out RMS square root 2 over R load, which will give you 8.425 square multiply with 20 ohm will give you the answer of 1436.5 watt. So this is the answer for question C. And what about question D? So question D is you need to calculate the power factor. So the power factor, if you recall, is actually referring to this angle of the power triangle. So this is your apparent power, usually referring to the source, and this is your P, and this is your Q. And from this equation, from this triangle, we can actually derive this formula as cos theta is equal to P, where cos theta here is already, you should know, is a power factor. So cos theta, which is the power factor, can be calculated by simply P over S. And you need to know that this P is referring to the P load. Okay, and this is the S source. So the P load is already known, which is 1436.5 watt over your S source. So your S source should be in terms of the RMS and IRMS. Okay, so the source is 1436.5 over your voltage source is 240 volt RMS multiply with the current source RMS is 8.4 to 5 ampere. Then this will give you the power factor, which is the cos theta is 0.7071, and this should be lacking. Okay, so thank you very much. That is the end of the solution for example number 1.